Welcome back to the Best Writing on Mathematics channel. In this video, I will give a brief summary of the 2011 edition of the print series with a similar name published by the Princeton University Press, which I edited over 12 years. Underwood Dudley argues that mathematics beyond the elementary notions is the best preparation for reasoning in general, and that most people value it primarily for that purpose, not for its immediate practicality. Dana Mackenzie describes the overt and the hidden properties of the Apollonian gasket, a configuration of infinitely nested tangent circles akin to a fractal. Rick van Grohl tells the story of finding the optimal number of steps that solve scrambled Rubik's cubes of different sizes, starting with the easy cases and going to the still unsolved ones. Andrew Schultz writes on the friendly professional interactions that shape the career of a mathematician, from learning the ropes as a graduate student to becoming an accomplished academic. In a polemical reply to a text selected in last year's volume of the series, the 2010 edition, namely the text by Gowers and Nielsen, Melvin Nathanson argues that the most original mathematical achievements are distinctively individual, rather than the results of collaboration. Martin Campbell-Kelly meditates on the long flourishing popularity and recent demise of mathematical tables. Ruben Hirsch ponders on the post-World War II abundance of Jewish mathematicians at American universities, in contrast to the pale pre-war representation of them among American mathematicians. David Hand points out that attributing the 2008 financial crisis to the widespread reliance on mathematical models of investment and risk oversimplifies causality in complex economies. Jordan Ellenberg describes how compressed sensing, a process based on a mathematical algorithm, leads to the reconstruction of big amounts of information starting from smaller samples. After reviewing the broad stages that led to computing as we know it, from a blend of applied mathematics, science, and engineering in the 1930s, continuing into the present, Peter Denning characterizes the interactions between computing and the other domains of science, physical, social, and life sciences. James Hamlin and Carlos Sequin identify the mathematical properties of Charles Perry's airy sculptures and extend those ideas by suggesting other ways of constructing transparent surfaces in a similar vein. Barry Cipra describes the Lorenz system of three simple differential equations, a versatile system with solutions of aesthetic interest but whose dynamic properties are only poorly understood by mathematicians. Doris Schatzschneider identifies the mathematical inspirations of the Dutch artist M.C. Escher, most of them fruits of long-term preoccupation with geometry and of his interaction with mathematicians. Counterbalancing the impression of fragility conveyed by the light structures presented in the Hamlin and Sequin text, Helaman and Claire Ferguson detail the mathematical notions underlying Helaman's massive bronze sculptures. John Mason recounts the main events, people, and trends that influenced his views of mathematics education over a half-century of activity. Douglas Fisher, Nancy Frey, and Heather Anderson discuss modeling, vocabulary enrichment, and group work as ways for engaging students in the mathematics classroom. Francis Edward Sue asks what makes a learner become an inquirer, and further a discoverer, and offers refreshing answers contradicting some of the widely held assumptions concerning the effectiveness of instructional approaches in secondary and undergraduate mathematics. Echoing the autobiographical tone in John Mason's text, Alan Schoenfeld reviews the ideas that guided him in researching mathematical problem solving and anchoring the role of theory in mathematics education research. Hans Niels Janke combines etymological considerations with the analysis of scientific thinking in ancient Greece to discern the sources and the changing meaning of the notion of mathematical proof. Jan Hacking asks what unifies and gives a common identity to varieties of mathematics, and concludes that the answer has changed through time depending on the contingent historical conditions. Feng Ye formulates several challenges that must be overcome by philosophers who claim that mathematical entities reside in imagination, in order to adopt a viable position, and provides grounds for restructuring such a philosophy of mathematics. Ivan Havel speculates on the possible mental imagery of number representation in connection with the polysemy of the concept of number and the unusual abilities displayed by people able to perform exceptional computations mentally. Yuan James reviews recent research on possible connections between characteristics of the autistic personality and salient features of mathematical talent visible in people affected by the syndrome. Chris Bod and Robert Eastaway take on the conundrum of communicating mathematics well to the non-specialized public and suggest balancing the symbolic language of mathematics with good examples of the imprint left by mathematics on everyday life. Marianne Freiberger explores connections between physics and the geometry of space, starting from conversations she has had with Xing-Tung Yao, one of the prominent geometers who studies them. To conclude this collection of articles on mathematics, Erika Clare explains how a computerized algorithm helps place in residency couples of medical school graduates, and how the process has changed over several decades to accommodate the transformation of the marketplace for doctors. Besides this text, I also included in this volume a list of also runs of notable other texts published roughly within the 2010 calendar year but didn't make it into the volume. Thank you for viewing and for listening to this video.